Hello Gems, welcome back to another video. So the grind for JEE 2023 is on and today we will be discussing mock test number 4. So far we have discussed mock test 1, 2 and 3. So if you have missed those out, you can check. The links are available in the description. Also mock test 4 is going to be on the easier side. Okay, so if you are first time over here, this is a perfect way to begin your grind with. Okay, so if you want something challenging, you can watch the previous mock test. Okay, so with that being said, let's begin with today's video. Questions for the day. Question number 1, we are supposed to find the dimensions of this quantity b square by mu naught. Okay, now there is a harder way of doing this. You might find the dimensions of b and then the dimensions of mu naught and then take that ratio, right? But the easier way of doing this is to relate it with something, okay, and that something is energy density. Okay, you might know the energy density in terms of electric field is given as half epsilon naught E square, and similarly the energy density in terms of magnetic field, if you want, it is b square by 2 mu naught. Okay, so this quantity will have the same dimensions as that of energy density. Okay, now what is energy density? Energy density is energy per unit volume. Okay, so you can take the dimensions here. 2 is dimensionless, so need not worry about that, and energy density is ml2t raised to minus 2. This is energy, right, half mv square, and that divided by volume. Okay, energy per unit volume. So the final answer that you get is ml to the power minus 1 t to the power minus 2, which is, I think, option C, right? So option C is correct. Let's move to question number 2. Okay, question number 2, we have a NCC parade which is moving at a speed of 9 kilometers per hour under a mango tree. Okay, there is a monkey on the mango tree at a height of 19.6 meters. Okay, he is going to drop a mango, okay, from this height. Okay, and the cadets are moving below the tree, right? So one of the cadets will gratefully receive this mango. Okay, you are supposed to tell what is the distance of this cadet during the time of release. Okay, so there is a typical way of proceeding with this question. It's very simple. Okay, so you can see motion in 2 dimensions. Okay, 2 independent dimensions. The cadets are moving in x direction, mango falling in y direction, right? And time is independent of frame of reference, at least for motions with small velocities. Okay, so here let us find the time taken by the mango to fall down. Okay, and that's our first job. Okay, so we'll use s is equal to ut plus half at square. Okay, now the mango is being dropped by the monkey. Whenever it says drop, the initial velocity is 0. It's just going to leave it. Okay, so when he leaves it, initial velocity is 0. So s is the distance is 19.6. We'll take downward direction to be positive for our sake. And here we have half. Acceleration, we are told to take it as 9.8. Okay, fine. So this is 9.8. And t square, so we are supposed to find time. That is our first objective. Okay, we'll find the time in y direction, we'll equate it to the time in x direction. Okay, time in y is time in x. Okay, so time does not have a frame of reference. Okay, so here 2 will go over here, 9.8 will come over here, this will be t square. 9.8 2 times is 19.6, so 2 into 2 is t square, which means t is basically 2. Okay, let's only take the positive value, so t is 2. Okay, so the mango will reach the ground in 2 seconds. Okay, so mango will reach the cadet, in other words, in 2 seconds, right? So so how far have this parade moved in 2 seconds? So that is our question now. Okay, so how far does this cadet, okay, this parade have moved? Okay, so time here, distance over here is, distance I'll write it as d, is speed into time. Okay, speed of the parade. So I want to find how far this parade has moved in 2 seconds. Okay, so knowing that, we can calculate which cadet receives it. Okay, so the speed of the parade is 9 kilometers per hour. So 9 kilometers per hour, if you want to convert it in meters per second, the conversion ratio is 5 by 80. Okay, so here you will get 5 by 2. Okay, that's your speed. So that is, or 2.5 I can say. So 5 by 2 into 2 seconds. Okay, that's perfect. So the distance that the parade has moved is 5 meters. Okay, so the distance that the parade has moved is 5 meters. So in order to receive the mango, the cadet, now just reverse engineer it, should be at a distance of 5 meters from the tree at the time of release. Okay, because the mango takes 2 seconds to fall, and the cadet can move a distance, the particular cadet can move a distance of 5 meters in 2 seconds. Okay, so the cadet was initially at a distance of 5 meters in order to receive that mango. Just reverse engineer. Okay, so our correct answer over here is option A, 5 meters. Over to the next question. Question 3 and 4 over here. In question 3, we have a balloon which has a mass of 10 grams of air in it. Okay, the air escapes from the balloon at a uniform velocity this. So if the balloon shrinks completely in 5 seconds, then the average force acting on the balloon is. Okay, so you can see that velocity is constant, but the answers are not zero, right? Force is mass into acceleration, but since the velocity is not changing, there is no acceleration, and since there is no acceleration, there should not be any force. Who says that? Okay, force is not equal to mass into acceleration. Yeah, I'm the first physicist to say that. Force by Newton's second law is actually dp by dt. Okay, this is a question of thrust force. Those who might directly know the formula can use it. Thrust force is u relative into dm by dt. Okay, so you can see that u relative, this velocity is basically relative velocity. This is velocity of air with respect to the balloon. So this is 4.5. You want the answer in dynes. Okay, or dyne. Dynes is the CGS unit of your force. Okay, so we'll keep everything in centimeter, gram and seconds. So this is u relative and dm by dt. So that is your mass. So since you want the average force, you can, in place of dm by dt, you can have delta m by delta t. You can take it for a larger interval, right? You want average, right? So we'll take 10 grams and it takes 5 seconds, right? 5 seconds to completely drain out that 10 grams. Okay, so the dm by dt is this, okay, delta m by delta t rather. So 4.5 into 2, which is 9. So option B is correct over here. And the thing that I was explaining over here is momentum is m into v, right? Now this is the rate of change of this, right? So if you see, this is m into v, right? So force is equal to mass into acceleration only when the mass is constant. Okay, mass comes out of this differentiation sign and dv by dt is acceleration. But in other cases where mass is not constant, here mass is escaping, right? The mass of the balloon is changing. Okay, so in that case, both are variables, so you have to differentiate both, right? So u into v, so u into derivative of v, mass into change in velocity, which is mass into acceleration, and then v into dm by dt. Okay, so in this case, this is the thrust force, okay, which is appearing over here. Okay, so although there is no change in velocity, okay, the gas is escaping out with uniform velocity, there is a thrust force, okay, which is due to this term v into dm by dt. Okay, so this is not 100% correct. There is a notch in that. It actually comes from conservation of linear momentum. I discussed this in my F not equal to ma video, old video, but basically you get the point, right? So this is the thrust force. Okay, so that's your answer 9. Let's come to this one. If you have the radius of Earth shrinks by 2%, mass remains the same, you are supposed to tell what will happen to acceleration due to gravity. Okay, so will it decrease by 2%, 4%, increase by 2%, or increase by 4%? Okay, so if you see the relationship between your acceleration due to gravity and your radius, it's gm by r square, right? G is equal to gm by r square. Okay, so if you see, they have told that m is constant, so g is inversely proportional to the square of that. So basically, if you are given the percentage error as 2, you can write it as 2 times delta r by r, right? The percentage error in this, or the relative error in g, will be 2 times delta r by r, because it is raised to the power 2, right? That is from the concept of errors. So into 100%, because we are given it in terms of percentage. So this term, we are told that the percentage error in the radius is 2%. So 2, this is 2, and this is 2%. So the error in G is 4%. Okay, so does it increase by 4% or does it decrease by 4%? You can see that there is inverse relation, right? So here we are told that the radius shrinks. Okay, it shrinks. So radius decreases, so your G should increase. Okay, which is option D. Okay, it increases by 4%. It's roughly 4%. Okay, approximately 4%. So that's from this question. Over to the next question. Now time for question 5 and 6. In question 5, we are asked for the force required to stretch the wire of cross section this to double its length will be. Okay, so we are supposed to tell what will be the force to stretch a wire to twice of its length. Okay, Young's modulus of the wire is given. So Young's modulus is basically stress by strain, right? Stress is force per unit area. So from there you can find. So you can clearly see that initially the wire has length L, right? You are going to stretch it. Okay, so its length will become 2L. Okay, so you can see that the strain is nothing but, what is strain? Strain is change in dimension to original dimension, right? So it's delta L by L. So you can see that delta L, change in length, is L, right? Change in length, if you see change in the length, so 2L minus L, which is L. And if you see the original length, so change in length to original length, change in dimension to original dimension. Okay, so strain basically is 1 over here. Okay, change in length, which is 2L minus L, which is L, and the original length is L. Okay, so strain is 1. So your Young's modulus will be just numerically equal to your stress. Stress is force by area. So you are supposed to find force. So force will be Young's modulus into area. The Young's modulus is given as 2 into 10 to the power 11. Now this is in newtons, right? You also want the answer in newtons. Okay, Newton meter square. So you want this to be converted in meter square. Okay, so this area 1 centimeter square, you can write it as centimeter is 10 to the power minus 2, so I think it is that squared, so 10 to the power minus 4 meter square. Okay, so you have the answers in CGS now, so it is 2 into 10 to the power 7. Okay, I think that is correct. So option C is correct over here. Let me check that. So 2 into 10 to the power 7. Yes, that's correct. Let's come to this one. Question number 6. We have a Carnot engine of efficiency 50%. Okay, so if the temperature of sink is reduced, the efficiency is going to increase, you know it. So it's reduced by 40 degrees Celsius. Its efficiency increases by 30%. Okay, so pay close attention to the question. Okay, the temperature of the source will be. Of course, the temperature of the source is not changed. Okay, so you are supposed to report the temperature of the source. Okay. So first of all, we will get two equations. Okay, you are just supposed to solve those two equations. Okay, so first equations comes from this. Efficiency of engine is 1 minus T2 by T1. Okay, so these are initial temperatures, suppose. Okay, so initial condition, the sink temperature is not manipulated, it's not reduced. So this efficiency is 50% or 0.5. Okay, 50% is 50 by 100, right? So 1 minus T2 by T1. So T2 by T1 will be, if you see, T2 by T1 is 1 minus 0.5, so which is again 0.5. So T2, you can write it in terms of T1. T2 is 0.5 of T1, right? So this is our first relation. Okay. Now T1, here you should know that T1 is the temperature of your source, T2 is the temperature of sink, right? Now we'll write the second equation. Second equation, we are going to reduce the sink temperature, which was T2 initially, we are going to reduce it by 40. Okay, now a reduction in 40 degrees Celsius, or you reduce 40 Kelvin, but it's delta T, right? So you need not convert it in Kelvins. Okay, so it's T2 minus 40. Okay, it's delta T change. Okay, that is reduced by that amount. Okay, so this is our second equation. Here, from here we'll get our second equation. Now pay very close attention to the question. It says that the efficiency increases by 30%. It does not mean that efficiency becomes 50 plus 30, 80. No, the question does not say that. It says that the efficiency increases by 30%. So initially it was 50% or 0.5, we can say 50 by 100. Now it increases by 30%. Okay. So what is the 30% of 50? Okay, so 30% of 50, you just multiply it by 0.3, right? 30% is 30 by 100. So this is 0.15. Okay, so this is the amount your efficiency is going to increase. So 0.15 plus initial 50%. Okay, it increases by 30%. Okay, it's not increases to 80%. Okay, it's not 50 plus 30, it's 50 plus this amount, 30% of 50. Okay, so that was a key point over here. So 15 plus that 0.5 will give us 0.65. Okay, so 1 minus T2 minus 40 by T1. Okay, are we supposed to solve this? Okay, let's solve this. So I'll multiply T1, I'll multiply T1 everywhere. Okay, so this is the equation that we end up with. Now what shall we do? We want T1, right? We want T1, and here we have a bracket, mind you. So T1, so T2 we can write it as 0.5 T1, right? So we'll use that relation. So T1 minus, we have 0.5 T1, okay, and this minus minus will be make it plus. Okay, so now this will again make it 0.65 T1. So this T1 minus 0.5 T1, it will be T1, and here we'll have plus 40. Sorry, T1 minus 0.5 T1, that will be 0.5 T1 plus 40, right? So let's do something. Let's take this to the other side. So it's 0.65 minus 0.5, which is 0.15. So that gives us 40. So T1 will be 40 by 0.15. Okay, T1 will be 40 by 0.15. Okay, now let's simplify this. This will, T1 is basically the temperature of source, right, which we are supposed to find. So 40, we can multiply it by 100 so that we can shift that. So here 5 3s I can say, right, 5 3s and 5 8s. So 800 by 3, 800 by 3, that is 2, 2 and remainder 2, 6 again, 2 6 are 18, 2 6 are 18, so 266 somewhere over there. Yes, option C, 266.7. Okay, that's your answer. I hope you got the thing. Okay, the key point was it's 30, it's not 50 plus 30, it is 50 and 30% of 50, which is 0.15. So 50 plus this amount. Okay, so that was the key point. I hope you got that. Let's move to the next question. So question 7 and 8 over here. Question 7 is a disgrace to JEE, I would say, because here you are given the wave equation and you are supposed to find the velocity of a wave. Okay, don't tell me you can't do that. Okay, so it's very simple. Okay, just you are supposed to use the formula velocity is omega by k. Okay, so everything is given to you over here. So it's coefficient of t upon coefficient of x. Okay, so here this factor is common. You can consider it, but anyways it's gonna get cancelled. So coefficient of t is 400 and coefficient of x is -1, but here it's the mod of that. So basically your answer is 400 meters per second. Okay, yeah, it was that simple. Okay, let's come to this one. This is a repeat question. So some of you who have done the previous few mock tests with me might have seen this question. Okay, so basically in this question we have two capacitors which are connected in series. Each of them have capacitance of 40 microfarad. Okay, but that's not the end of it. You are going to fill one capacitor with your dielectric of some dielectric constant k. Okay, you are supposed to find the value of k if the equivalent now becomes 24. Okay, so if you had 40 and 40 in series, the equivalent would have been 20, right? But now we have something with the dielectric. So this is 40, of course, no dielectric, nothing. Okay, and this will become k times of 40, right? Because whenever you introduce a dielectric, the capacitance becomes k times of the initial capacitance. So it will become k times of 40, basically because your epsilon itself becomes k times of epsilon naught. Okay, so now equivalent will be given as C1 into C2 by C1 plus C2, right? So C1 is 40k, C2 is 40 upon C1 plus C2. So 40k plus 40. Actually, we can take 40 common everywhere. 40k upon 40, and here we'll have 40 upon k plus 1. Okay, and this equivalent is given to us as 24. Okay, and everything is in microfarads. Okay, so this will cancel. So this goes to the other side. So 24k plus 24. Okay, just multiply that, and here we'll have 40k. Okay, so 40k minus 24k, I think that's 16. So 24 is equal to 16k. Okay, just solving it now. K is equal to 24 by 16 or 3 by 2. Okay, yes, 8 3s are 8 2s are, and that should give us the dielectric constant to be 1.5. Okay, so that's your answer. It's a repeated question. Okay, this question repeated in 2 shifts in 2022. Okay, so JEE does repeat questions. So this was the only one repeating question, of course. So yeah, I cannot say that JEE repeats question all the time, but this one has repeated in the 2022 papers. Okay, so these were the answers. Over to the next question. Question 9 and 10 over here, you can actually give a genuine shot to question 9, not that short, So just try it. Okay, you can pause the video here and try question 9. Okay, and if you get the answer as 4:1, it's incorrect. Okay, so let's do it. So here we have a resistance R1 which is drawn so that its length is increased by twice of its original. Okay, so suppose we have a wire of length L and area A. Okay, so this is the original resistance. Let's call it R. Will be rho L by A. Right, now we are going to draw a wire of resistance R1. Okay, so that its length will be increased by twice. Okay, so the increase in the length of this wire is 2L. Okay, this is the increase, and original length was L. Right, so you are going to stretch the wire. Drawn, basically, whenever the words drawn or stretch is used, you are basically stretching that wire drawn from this. Right, so stretching that wire so that its increase in the length is 2L, twice the original length. Okay, so here the resistance will be rho and rho. The length is 3L, right? L plus L, rho L length by area, right? What will be the area over here? Same A? No. Okay, the area will change because since you are stretching it, the area will decrease. Okay, and it shrinks to A by 3. So basically, A into L should remain constant. Okay, A, whenever you are stretching a wire, remember that A into L is always constant. Okay, so if length becomes 3 times, okay, area should fall to A by 3. Okay, so that when you multiply this 2, 3 cancels and AL is constant. Okay, initially it was A into L, and here also if you multiply this 2, you will get A into L. Right, so whenever you stretch a wire, remember that this ratio is constant. Okay, so now we are supposed to find the ratio of the new resistance to original resistance. Okay, so new resistance is R divided by the new resistance is R1 divided by the original resistance, which is R. So rho will get cancelled. If you see here, you can see basically 9 times rho L by A. Right, this 3 goes on top, and this is 9 times rho L by A. Right, so if you see we have R1 on top. Right, so 9 times rho L by A will get cancelled and will be left with 9. Okay, this goes on top, right? R1 by R. So now all of this gets cancelled. We are left with 9, which means the correct ratio is 9:1. Okay, here the language was just a bit twisted. It said increased by twice of its original length. So increase in length was 2L. Okay, so the total length of the new wire was 3L. Okay, now let's come to this one. Here we have been given the we are asked what can you do to increase the current sensitivity of a galvanometer. Okay, now the current sensitivity is given as NBA by K, right? So this basically comes by equating your torsional force, your torque, to your actual torque in the coil. So NIAB. So if you want your sensitivity, it is theta by I, the change in division per unit current. Okay, so theta by I will be NBA. You can see that it will be NBA by K. Okay, so that is how this formula comes. This is current sensitivity. Okay, current sensitivity. Okay, now if you see option A says if you decrease the number of turns. If you decrease the number of turns, this is directly proportional. Okay, so current sensitivity will decrease. Okay, so that's not correct. Option B says increasing the magnetic field. Okay, if you increase the magnetic field, yes, it is directly proportional. It will increase your current sensitivity. Now option C says decreasing the area of coil. If you see again, it's directly proportional. So if you decrease the area, current sensitivity will decrease. And option D says decreasing the torsional constant. Torsional constant of spring is this K value. So if you decrease that K value, it is inversely proportional, right? So if you decrease that K value, current sensitivity will increase, right? Decrease the denominator, current sensitivity will increase. Okay, so option B and D. So B and D only. Okay, so this is the way of asking multiple choice question in multiple correct choice questions in a single correct choice exam. Okay, that is how they pull off tricks. Yeah, so you should be ready for everything. Over to the next question. Let us come to question 11 and 12. In question 11, we have a wire which is carrying some current, which is placed on an inclined plane. The inclined plane is making an angle of 45 degrees with the horizontal. Okay, you are supposed to tell what should be the minimum current that this wire should carry for it to remain stationary. Okay, there is also magnetic field over here. The direction of the magnetic field is vertically upwards along the y-axis, you can say, and the magnitude is 0.15. Okay, so basically this is a question based on equilibrium, right? So if you see, we can break the weight of this wire. Of course, the wire will have some mass. Okay, so we can break its weight into two components, mg sin theta along the incline, right? Remember, so mg sin theta is along the incline and mg cos theta is perpendicular to the incline. Now the component which is perpendicular to the incline will be balanced by the normal reaction, so we don't have to worry about that. Okay, so what about this force mg sin theta? Now if you see, there will be some force on the wire itself, right? It is a current carrying wire and it is placed in a magnetic field, right? So there will be some force on this wire, okay, and that force will balance this mg sin theta. If you don't believe me, you can check the direction of that force. So if you see, the direction of the force is given as, for your magnetic force, the force on a current carrying wire due to a magnetic field, it's given as L cross B. Okay, L basically has the same direction, that of current. So if you see, direction of current is along the incline. Okay, along the incline, it's going into the plane of this board, right? So it's going into the plane of this board. Direction of B is like this. So if you curl your hand from L cross B, right, L to B, so if you come from L to B, okay, so you can see that the force will be in the upward direction, up the incline. Okay, so here in this direction you will have ILB, okay, ILB sin theta, okay, IL cross B sin theta. Okay, so these two forces, when they cancel out each other, this wire will remain stationary. Okay, and that is what you are supposed to do. You are just supposed to equate mg sin theta to ILB sin theta. Okay, sin theta and sin theta will get cancelled. So now we are supposed to find L. Here we are not given the length of the wire, but we are given the line density. So we are given m by L. Okay, so kg per meter, right? So m by L is given. G is taken to be 10. So G, and what we'll do? So m by L is gone, and by B, right? So by B. Okay, so here on the right hand side we'll have I. Okay, so what will be the value of I? Here we'll get 0.15, G is 10, and I think this is 0.15, right? So this is 3 times, right? 15 3s are 45 and 3 10s are 30. So answer should be 30 amperes, not newtons, not force, it's current, right? So option A, 30 amperes. Okay, that's your answer. Here you just have to equate mg sin theta with IL cross P. Okay, those two forces are opposite to each other, and if they equal each other, they will cancel out each other, right? So now let's come to this one. Here we have a purely inductive circuit. Here the equation of the current in the circuit is given. We are supposed to guess the equation of voltage in this circuit. Okay, the inductance is also given. Okay, take pi as 22/7. Okay, very simple, because in inductor we know that Li, right? In inductor the current lags. Okay, in inductor the current lags. Okay, so here we have our voltage, right? So here we have our current, right? So here in inductor current lags and voltage leads. Okay, this lags and voltage leads by 90, and this lags by 90. Okay, so leads by 90 degree and this lags by 90 degree. So we are given the equation of current. We know we want to go to the equation of voltage. So voltage will lead the equation of current by an angle of 90 degree. Okay, so here we have 49 pi t minus 30. So in order to go to voltage, this is current equation, right? In order to go to voltage, voltage leads in an inductive circuit, the voltage leads by 90 degrees. So you have to add 90 degrees to this. Okay, so if you add 90, you will get plus 60, right? Minus 30 plus 90 plus 60. Okay, so it's either this one, option B, or option C maybe. Okay, so option B or option C. Okay, now you are supposed to find these values in order to compare that, and that can be found. So V equation will be V naught. This is basically I naught sine the phase, right? So here we'll have, say similarly, this will be sine 49 pi t minus 30 plus 90, since the voltage leads, so that brings us to plus 60, this phase, this or this. So V naught, how will you find V naught? V naught will be I naught into XL, right? XL is the the impedance of this circuit. It's purely inductive. Okay, so it is given as omega L. Now omega, you can see it is 49 pi, right? Omega t minus phi. So omega is 49 pi, pi is taken to be 22/7, and so 49 pi is omega. L, we are given it as 30 millihenry, 30 into 10 to the power minus 3. So 7 7s are 49, 7 into 22, or I can say it's 7 into 7 3s is 21, right? 7 3s are 21, and we can cancel off 1 0, 10 to the power minus 2. So 22 into 21. So I think 21 into 21 is 441. To that you add 21, so 462, if I'm not wrong. So 462 or 4.62, since 10 to the power minus 2. So here we have I naught as, sorry, XL as 4.62. I naught is the maximum current, which is this. Okay, I naught sine this, right? So this is I naught 5. So if you want to multiply by 5, divide by 2. Okay, so 2 3 1. Okay, so 2 3 1 and shift the decimal. That's a mental math trick. Okay, so that's your answer, which is option C. Okay, sorry, it's not option C. We want the phase to be 60 degrees, so it's option D, right? Yeah, it's option D. Over to the next question. Now let us come to question 13 and 14. In question 13, we are supposed to find the velocity of light in medium 2. Okay, here medium 1 is just given for misdirection. Okay, the velocity of light in medium 2 will not depend on its history, what happened in medium 1. So basically velocity, if you are given the permeability and permittivity, the velocity is given as the square root of their product. Okay, so the reciprocal of the square root of their product, this formula. Okay, so now here we are given the relative term. So relative permeability will be permeability in the medium divided by mu naught. Okay, so if we want mu, okay, so which we want in the formula, mu will be given as mu r times mu naught, and similarly epsilon will be given as epsilon r times epsilon naught. Okay, so mu naught times mu r, and here we'll have epsilon naught times epsilon r. Okay, in place of mu and epsilon. Okay, now this formula you might know that 1 upon mu naught epsilon naught, the root of that is nothing but it's the velocity of light. Okay, it's c in free space, in a medium, in air you can say, in vacuum you can say. Okay, and here we'll bring together epsilon r and mu r. Okay, so this is nothing but c. Okay, so here we'll do, so this is c. C is 3 into 10 to the power 8. Okay, so this is c. Okay, and that you see is 1 upon square root of multiply this mu r into epsilon r, right? So it's 1 upon square root of 9. Square root of 9 is 3, right? Square root of 9 is 3, and 3 and 3 will get cancelled, and the answer that you get is 10 to the power 8 meters per second. Okay, so that's your answer. That's the speed in medium 2. Okay, let's come to this one. Here we are given two statements. Okay, so statement 1 says that the average momentum of a gas molecule in a sample of ideal gas depends on temperature. Okay, which might seem logically true, but it is not, if you see. Okay, so here if you have the sample of ideal gas, okay, so here if the a particular gas molecule has velocity in this direction, momentum in that direction, there will be always some other molecule which has a velocity opposite to that, a momentum opposite to that. Okay, so basically in the gas sample, okay, the momentums will be randomly oriented, and on an average they will cancel out each other. Okay, so for every momentum in a particular direction, there will be some other molecule with the momentum in the opposite direction. Okay, so basically they will cancel out each other. Okay, and that's the end of the story. Okay, so the average momentum of a sample of ideal gas is 0. Okay, it does not depend on temperature, it's always 0. Okay, so the statement 1 is false. Okay, so if you see, only option D says that statement 1 is false. We shall also prove that statement 2 is true. Here in statement 2, we are given that the RMS velocity of oxygen, so first of all RMS velocity is given as under root 3 RT by m, right, where m is the molecular mass. So oxygen is V. Okay, so if you double the temperature, so what will happen, where can we do that? We'll do that here. So we are going to double the temperature, and what we are going to do, when you double the temperature, what happens is that the oxygen molecules dissociate into oxygen atoms. Now this might not seem of that importance, okay, when you just read it as a sentence, but what happens is that when they dissociate, this molar mass will change, right? Now usually initially originally they represented oxygen molecule, right, for velocity v, oxygen molecule, okay, their mass is 32 grams, okay, and when they dissociate, their mass is 16 grams, okay. So basically the mass splits, right, mass becomes half, so this will also become m by 2, okay. When they dissociate, the molar mass reduces to m by 2, okay, half, okay. So here if you see your velocity, so basically it will become 4 times 3 RT by m, square root of that, okay. So you can write it as 4 out of the square root sign, and root 3 RTM, that's the initial velocity, RMS velocity, root 3 RT by m. So yeah, so now your velocity, now the RMS velocity becomes 2 times of v, okay. So yeah, your statement 1 is false because average momentum is 0, and statement 2 is true because the velocity, RMS velocity, indeed becomes twice, okay. So that's from question 13 and 14. Over to the next question. Now question 14 and 15 over here. In question 14 you are given an equation using which you can find the de Broglie wavelength of an electron. Here x stands for what, okay. You are supposed to tell what does this x stand for, okay. Now the letters have their usual meaning. M mass of electron, k is the kinetic energy, to here p is momentum, k is kinetic energy, v is capital V is the voltage, okay. Now I don't know any better way of doing this, but to remember it as a relation, okay. So the relation itself says that 1.227 in nanometers, okay. This is given as under root V. Actually this is a relation for between stopping potential and this wavelength, de Broglie wavelength, okay. So this relation says that, okay. So here the correct answer for x should be root of V, okay. Actually everything is correct if you see. So lambda is given as h by p, you can write it as under root 2 mk, okay. So unless you substitute the values and find out, only then can you know that these are not the correct answer. You have to substitute the mass of electron, the 2, and then value of h, and in place of k you can put q into capital V, right, in terms of stopping potential, and then only you can see that it's this relation, okay. So my recommendation is to remember this relation as a relation itself, as an equation itself, as a formula itself, that lambda is given as 1.227, that is in angstroms, and divided by the square root of your stopping potential, okay, and that is in nanometers, right. So let's come to this one. Here we are given that the half life period of a radioactive material is 60 days, the time taken for 7 by 8 of its original mass to disintegrate, okay. Now this can be easily done by the formula n by n0 is half small t to capital T. Capital T is half life, small t is the time taken for this disintegration to happen. Now keep in mind that this n, small n, this n, capital N, stands for the concentration which is left after time t, okay. 7 by 8%, okay, that fraction has disintegrate, okay. So originally it was n0, of course, and 7 by 8 of n0 has disintegrate, okay. So the amount remaining is the amount n, okay. So that is a very important point to remember. So it is n0 by 8, 1 minus 7 by 8, 1 by 8, okay. So here in place of n you will put n0 by 8, here we'll have n0, they can get cancelled, here we'll have half, and to the power small t by capital T. Capital T is half life, okay. So this 8 can be written as 2 to the power 3, and this also write it that way. So this 3 should be equal to this, right. So bases are same, the powers should also be same. So small t by capital T. So small t, the time taken to for this amount to disintegrate is 3 times capital T. 3 times capital T. Capital T is half life, so 3 into half life is 60, 3 6 are 18, 180 days, okay. 180 days, option C is correct. Over to the next question. Question 17 and 18, the previous two question numbers were question 15 and 16. I might have made a mistake over there in the question numbers. Okay, so in question 17 we are supposed to identify the correct characteristics from below of that of a solar cell. Okay, so solar cell basically supplies your current to the load, so it should have a graph somewhere in the fourth quadrant. Okay, so if you see all of this graph, only this one is there in the fourth quadrant, so option B is correct. Okay, so it has graph in the fourth quadrant because it supplies current to your load. Okay, other way around. So here this will be the open circuit voltage. You might have seen these terms in your NCRT, and this is the short circuit current. Okay, so yeah, that's about it. That's the correct characteristics of your solar cell. Let's come to this one. Here we are supposed to tell the ideal value of your mu. Mu is the modulation index, which is often defined as AM by AC, right? So what should be the value of this modulation index to avoid distortion? Okay, so basically if you want to avoid distortion, the carrier wave should have a higher amplitude, okay, so that it is able to carry this signal, this modulator signal, to a longer distance, and the loss of power is less. Loss in power is less. Okay, so basically the carrier wave should have a higher, so the carrier wave should have higher amplitude than your modulated wave, so that it can carry it. Okay, so in the best case, in the worst case, or whatever, the it can be equal. Okay, that's the maximum threshold. So it should be for ideal, for if you don't want distortion, this value of AC should be always greater than or equal to AM. Okay, so this mu value, so if you see AC is greater than AM, so of course denominator is greater than the numerator, so the ratio will be less than 1, right? And maximum, when they are equal, the ratio will be equal to 1. So the ratio should be less than or equal to 1. You might have heard the value of mu in some cases when you solve numericals to be given as 0.8. Okay, it's one of the ideal values for your modulation index. Okay, so of course mu should be less than 1, less than or equal to 1, okay, to avoid distortion. So over to the next set of questions. Come to question 19 and 20, the last two questions from the MCQ side. So question 19, we have for a normal adjustment of a refractive telescope, the distance between the objective and the eyepiece is given, which means it's the length of the tube, right? Then the focal length of the, you are supposed to tell the focal length of the objective when the angular magnification of the telescope is 2. Okay, so basically again framing two equations and solving them. Okay, so magnification in normal adjustment is FO by FE. This is given as 2. Okay, so since we are supposed to find FO, you can write FE in terms of FO, which will be FO by 2. Okay, so FE, take it over there, and magnification is 2. So FE is FO by 2. Now we are given the length of the tube. Length of the tube is this 30 centimeters, which is FO plus FE. Okay, the distance between this eyepiece and the objective is nothing but FO plus FE, and that is given to be 30. Alright, so in place of FE I'll put FO by 2, so FO plus FO by 2. Now this will be 3 FO by 2, right? 1 and 1.5, so that is 1.5. So this is 30, cancel, 10, FO is nothing but 20. Option E. Okay, let's come to this one. Here we have a body of mass m. This system is in equilibrium. Okay, body of mass 5 kg. Okay, this system is in equilibrium. You are supposed to tell what will be the force on this particular spring. Okay, now the spring, you can clearly see it is balancing this component along the inclined component of the weight, which I told you it is mg sin theta, right? Along the incline mg sin theta, perpendicular to the incline mg cos theta. Now this is spring force, right? So spring force will be nothing but mg sin theta. Very straightforward question. So m is 5, g is taken as 10, sin theta sin 30 is half, this 5 times 5 is 25 newtons, which is option B. Okay, so that's from these two questions, the final two questions from MCQs. Let's move to the numerical type questions. Come to the numerical types, question 21 and 22 over here. We are told in question 21 that the projection of this vector on this vector is 0. You are supposed to tell the value of alpha. Okay, Now projection, what do we mean by that? Basically dot product is nothing but projection of a vector on another vector, right? So you are just supposed to take their dot product and equate that to 0, because dot product is nothing but the projection of one vector on other. So 2 times 1, that is dot product. Okay, so I'm multiplying xx, yy, zz. Okay, so 2 times 1, 2, 4 times 2, 8, and we have minus 2 times alpha. So minus 2 alpha is equal to 0. Okay, this is 10 and this is minus 2 alpha. You can clearly see that alpha from here will be 5, right? 2 alpha is 10, so alpha will be 5. So the correct answer over here is 5. Okay, such a simple question, right? Let's come to this one. We are told that we have freshly prepared a radioactive material which has a half-life of this. It emits radiation which is 64 times the permissible safe level. Okay, so if you want to work with the sample, how much time you should wait, okay, in order to work safely with this source. Okay, so since the radiations are 64 times more than the permissible level, we'll wait till the concentration becomes, the final concentration becomes 1 upon 64 times the initial concentration. Okay, that time the intensity will reduce, and that time you can work safely with the source, right? So again we can use the same formula. N by N0 is half T by T. Okay, so here N by N0 is nothing but N by N0. If you see, the ratio will be 1 by 64, and this will give half by small t to the capital T. So small t is the time taken and capital T is your half-life. Okay, and keep in mind that the answer that you want is in hours. Okay, so especially in this type of questions you should be very careful about the units. Okay, now let's come over here. So 64 is nothing but 2 to the power 6, right? 32 is 2 to the power 5 and this is 2 to the power 6. Okay, so if you compare on both the sides, this should have the same powers. Okay, so the time taken will be 6 times the half-life. The half-life is 2 hours 30 minutes. Let's keep it in hours. So 2 hours and 0.5, right? 2.5, that is half an hour, right? So 2, I can say 5 by 2, right? 2.5 is 5 by 2, and this will give us 15 hours. Okay, so correct option or the correct integer is 15 over here. Over to the next question. Question 24 and 25. In question 24, we are performing YDSA experiment with a laser of 560 nanometers. Okay, that is the wavelength of the laser light. Okay, it produces an interference pattern with the beta, the distance between the fringe width basically, as 7.2 millimeters. Okay, now use another source of light. Okay, this produces a fringe width of 8.1 millimeters. You can note that we did not change the setup, right? So beta is given as lambda capital D by small d. Okay, so if you see, we did not change capital D and small d, we only changed the source. So you can directly see that beta is directly proportional to lambda over here. D, capital D and small d has not been changed in this case. We are using the same setup, only two different sources of light. Okay, so you are supposed to find the wavelength of the second light. Okay, so basically beta 1 by beta 2 will be lambda 1 by lambda 2, direct relation, right? So beta 1 is given as 7.2, this is 8.1, lambda 1, the initial wavelength 560, okay, lambda 2 the wavelength of the other source, that will be, if you, now let's solve it. So lambda 2 will be 8.1 by 7.2 into 560. So it is 9 9s are 9 8s are. Is 560 divisible by 8? Yeah, it's 7s are, right? 8 7s are 56, and this will be 630. Okay, so your answer should be 630 nanometers. Okay, so the wavelength of the second source that we used is 630 nanometers. Okay, let's come to this one. Here we have a potentiometer which is connected to a 4-volt battery and a resistance box. Okay, now we are removing out certain resistance R from this resistance box. Okay, so the resistance box will also have some resistance R. Okay, so the null point for another battery which is connected like this is at a distance of 60 centimeters. Okay, this length is given as 300 centimeters, the total length, and the wire itself has a resistance of 20 ohms. Okay, So the balancing point for this 20 millivolt cell comes at a point 60 centimeters. Okay, 60 centimeters from the point A. Of course, you are supposed to tell the value of R. Okay. Now it's basic comparing of cells. So E1 by E2, you can use that formula, is L1 by L2. Now E1 is the potential drop of this cell. No, potential drop across the wire. Okay, remember that E1 is the potential drop across the wire. Since here there is resistance box, we are just supposed to consider the potential drop across the wire. Okay, the entire potential will not drop across the wire. Some will be lost in the form of heat in the resistance box, and here we'll have some potential drop over here, okay, across AB. So it is a split between them, not 50-50, but some split, some kind of a split. Okay, so we are E1 is the potential drop across the wire. Okay, so how will you find E1? E1 will be basically the total voltage. We are using the voltage divider rule. Okay, so the total voltage into the resistance of the particular wire. Okay, so 20, and plus in the denominator you'll have the resistance of the wire plus the other component. So the resistance of the wire, the other component is the resistance box, right? So that is E1. Okay, so 20 times V is nothing but 4, right? So 4 to the 8, so 80 by 20 plus R we can write. Okay, so 80 upon 20 plus R, and E2 if you see is 20 millivolts, so 20 into 10 to the power minus 3, and here we will have L1 and L2. L1 potential drop across the wire of length 300 centimeters. Okay, so we'll keep it in centimeters, and this distance for the balancing point for E2 is 60. Right, this cancels, 6 5s are 30. Okay, let's do it somewhere. 6 5s are 30. So and now we are supposed to find R, right? So R will be given as, so we can take this to the other side. So 80 divided by 20 into 1000, is it 10 to the power 3, right? And I think this is divided by 5. Okay, I hope I didn't make any mistakes. Let's check it. Okay, R will be so just a slight mistake over here. Here it should be R plus 20. I had taken R plus 20 on the other side. So now we should get the correct answer. This is 44 by 5 is nothing but it's 0.8, right? 0.8, and this is 10 to the power 3. So this is 800. 800 minus 20, that will be R, which is 780. Okay, so 780 is the correct choice. Over to the next question. 25 and 26 over here. In question 25, we have two electric dipoles, this and this, which are placed in a uniform electric field respectively. So this is placed in this electric field, this is placed in this electric field. You are supposed to tell what is the ratio of the maximum torque. The ratio will be 1 by x. You are supposed to tell the value of x. Now the torque on electric dipole is given as P E sin theta, right? P cross E. So the maximum dipole will be when sin theta is 1, right? Sin takes values from 0 to 1. So maximum torque will be when sin theta is 1. So I can write torque on first one is PE1. So I am omitting sin theta because it is 1, and PE2, P2E2. Okay. So P for the first one is 1.2. Now you can neglect the powers because they will get cancelled anyways. They are same. You can see. So E1, if you see P1, E1. So here we have it. Then P2, this one, and E2, which is 50. Okay, so 2L 2s, and this is 5 3s. So 1 by 6 you'll get. So here it's 1 by x. X is nothing but 6. Let's come to this one. Here you are supposed to tell the frequency of echo. So here we have a train which is blowing this frequency, moving towards a hill with this velocity, 36 kilometers per hour. That is, if you see, it is 10 meters per second, right? So 18 2s. So this is 10 meters per second. Okay. Now you are supposed to tell what will be the frequency as heard by the train driver. So the train driver is also moving. So for the apparent frequency, we have the simple formula: velocity of sound minus velocity plus or minus velocity of observer, velocity of sound plus or minus velocity of source. Okay, and this is into the original frequency, which is that 320. So if you see, velocity of sound in air is 330 Now if you see, the observer is trying to move towards the hill, right? So what will he do? He will try to increase the frequency, right? He's trying to hear the echo, he's moving towards the hill, so more number of waves will reach him in a unit time. He's trying to increase the frequency, so plus 10, okay? So he will increase the numerator. Similarly, if you see the source, which is the train, is moving towards the hill again we are looking for our echo, okay? So if you see, the train is also trying to increase the frequency, it's moving towards the hill, right? It's trying that the echo reaches the more number of waves reaches the driver in an interval of time. So it will try to decrease the denominator, okay? Increase the numerator, decrease the denominator, so that the frequency is more, okay? So there is actually a whole video on this. I made this a few years back on how to decide signs in Doppler's effect. So if you are confused, you can check that out, okay? And the original frequency is 320, okay? So if you see, this is 320, 320 will get cancelled, and the answer will be left with 340, right? 330 plus 10, which is 340. So that's your answer. Over to the next question. Question 27 and 28 over here. In 27, we have a block of mass m, which is as shown, okay? It initially has a kinetic energy E. With this energy E, it is going to compress a spring. So at some distance, when the distance of compression, the amount of compression is 25 centimeters from the natural length, the speed is halved, okay? So the speed, suppose initial is v, it becomes v by 2 when it compresses a length of 25 centimeters, okay? You are supposed to tell the spring constant, it will be in the form of Ne. You are supposed to tell the value of n. Here E is the initial kinetic energy, right? So basically you can use the conservation of energy. So the loss in the kinetic energy will be gain in the potential energy of the spring, right? So loss in kinetic energy, if you see, the initial kinetic energy is E, and then the speed is halved, so the kinetic energy will become E by 4, right? Because if you see, it is proportional to v square, okay? So when the speed is halved, E dash will become half mv by 2 square, okay? So you can see it is half mv square and 1/4 of that, okay? So this becomes E by 4, right? Excuse me. So when velocity is half, kinetic energy becomes E by 4. Now the gain in the potential energy, that will be half k delta x square. Now delta x, the extension here, the compression will be 25 centimeter, and that's squared, right? So I'll write it that way first. So this will be 3e by 4. Now this is half, and here we'll have k into 25 into 25, and this is 10 to the power minus 4, right? Centimeter square, so 10 to the power minus 4. Okay, so let's simplify this. Actually, you can cancel this. So we have 3e by 2. Okay, let's take everything to the other side and solve for k. So in the denominator, we'll get 25 into 25, and in the numerator, we'll have 10 to the power 4, right? That will go down and go up as 10 to the power 4, or 100 into 100, I can say. Okay, so I think 25 2s are, so this is 50, 50 2s are, right? This is 25, 25 4s are, right? So 2 4s are 8, and 8 3s are 24. So this answer that we get is 24e. Okay, so k is nothing but 24e, n is 24. Okay, so that's your answer. Let's come to this one. Here we have some identical discs in this arrangement. You are given that the moment of inertia about OO dash, this axis is given as this, where A is the diameter. Keep that in mind. Okay, so here you are supposed to find the value of this x. Okay, now first of all, let's compute the moment of inertia about OO dash. So this disc and this disc, if you see, it's symmetrical, right? It's about the axis symmetrical, and this disc is also symmetrical. They are identical basically. So the arrangement is symmetrical. So you can find moment of inertia for this disc multiplied by 2, this disc multiplied by 2. Okay, so I'm multiplying 2 times the moment of inertia of this. Okay, so if you see that OO dash is along the diameter, right? Along the diameter, the moment of inertia for a disc is 1/4 mr square, right? If it's perpendicular to the axis of the disc, okay, to the disc, okay, normal to the plane of the disk, then it's half mr square. But if it's along the diameter, like in this case, it is 1/4 mr square. So 1/4 mr square, 1/4 mr square. So again, it's half mr square, right? So it's 2 times 1/4 mr square. Now, what about these two disks? These two disks will have to use our parallel axis theorem. So I'm clearing this off, okay, just to solve it. Okay, so now we'll have to use parallel axis theorem. Okay, so here first of all, we can see that only for one disk we'll find and multiply it by 2. So we'll find the moment of inertia for a axis. So parallel axis theorem says that the moment of inertia about this OO dash will be moment of inertia about center of mass, total mass, distance of separation squared, right? So a moment of inertia about center of mass, we already know it's about the diameter, that will be 1/4 mr square. Remember, the discussion is going in mr square. Finally, we'll convert it to a, right? Finally, we'll convert r to a. Okay. Now, this is moment of inertia about this axis, right? So, if you want about OO dash, you'll have to add m times the total mass times the distance between the two axes. Now, what is this distance? Now, the diagram is not proper, so it was something like this, and this. Okay, so the distance is basically r. Okay, it's not clearly seen, but the distance was r. Okay, I was not able to draw it properly, so the distance between two axes was r. Okay, so this will be half mr square, and if we compute this, this will be 5/4, right? 1/4 plus 1, so 5/4, 5/4 again into 2, so 5/2 mr square, right? So this will be 6/2, which is 3 mr square. We are not done yet because you have to convert r to a. So radius is half of diameter. Okay, so you get 3 ma square by 4. So if you compare that, x/4 ma square, 3/4 ma square. X is nothing but 3. That's your answer. Hope you were able to understand it. So over to the next question. So question 29 and 30 over here, the last two questions for the day. Question 30 is your homework question. You'll do it and let me know the answers in the comment section. And by the way, this is the correct figure for the last question. Okay, I had drawn it the other way around, so that was wrong. So this figure is the correct one, that you are supposed to find the moment of inertia. Now it is clear that the distance between the two parallel axes is r, right? The distance between OO dash and the one that is passing through the center of mass of the disk is r. Okay, now it's clear. So let's come to this one now. Excuse me. So question 29, here we have a air bubble of diameter 2 centimeter, which is rising from a liquid which has density this. Okay, and it is moving steadily with this velocity. Okay, 0.35 something. Okay, so this should click you somewhere that it is moving steadily with a certain velocity in a liquid. So it is prompting you somewhere. You are supposed to find the coefficient of viscosity in poise. In poise meaning CGS unit. Okay, so the thing is, this is prompting you to terminal velocity. Okay, this is the terminal velocity of the air bubble, because it's moving steadily means that the forces on the air bubble are balanced. Okay, and how is terminal velocity given? 2/9 r square g rho minus sigma upon eta, right? So from here you can write the equation for eta, 2/9. Now r square, here r square is 2, no, its diameter is 2, radius will be 1. So we want everything in CGS, so 1 square, which is 1, g will keep it as 10, and then excuse me, then rho will be the density of the liquid, 1750. Now this is in kg per meter cube, so kg is 10 to the power 3 grams and meter cube is 10 to the power 2 centimeter, 100 centimeters, right? 1 meter is 100 centimeter, and that to the power 3, 6. So we'll have effectively 10 to the power minus 3. Okay, and finally if we divide this by Vt, okay, Vt is 0.35, okay. Now if we solve this, let's solve this. I think what I'll do, I'll multiply by 100. Okay, so what will happen, 10 into 1750 into 10 to the power minus 3 into 100 upon 35 will get, right? So I think I can cancel something, this and this I can cancel, right? 110, 1000, and this I can cancel. So 2 by 9 into 1750 by 35, right? So 5 sevens are 5 threes are, okay, 5 threes are 15, 16, 17, 5 fives are 5 zeros are, okay, fine, 7 fives are, so this is 50, so 50 into 2 is 100, 100 by 9, I think 100 by 9 is 9 ones are, again 9 ones are with the remainder of 1, so 1 1, okay. So you are supposed to tell the answer to the nearest integer, which is 11. Okay, if you round that off, that will give you 11. Okay, so that answer is 11. This is something that you'll tell me in the comment section. So do give it a try. And that's pretty much it for today's video. I hope you enjoyed it. I hope today's paper was much more easy and trivial than the previous ones that we discussed. So yeah, that's all for today. I'll see you soon in the next video. Till then, keep enjoying physics.